Can everyone hear me? Cool. So this case study is entitled Security Change 3 Feedback at Riot Games. So my name is Mark Hillick. I work in security at Riot Games. I've worked there since 2013, so just over 5 years. And today I'm going to tell you a few stories about how we moved to the cloud, the mistakes that we made, how we corrected some of those mistakes, and the direction that we're going in the future. And I'm going to talk about some of the tools that we've used. So, hands up, who plays video games? Cool. Anyone play League of Legends? Or does everyone play Fortnite now these days? Cool, awesome. So, I've been in the industry 17 years. I've done a bunch of SANS courses, GSE cert. I've created CTFs and done some volunteer work. And at Riot, I get to combine two of my passions, so security and gaming, along with some surfing. So I live in LA now. As you can probably detect from my accent, I'm not from the US. Although apparently when I go home, people think I'm from Canada. And given the past weekend, I'm not sure if that's a good thing. But on a serious note, I'm much happier living in the SoCal bubble. A lot nicer weather and a lot less rain. So a few stats on Riot Games. So we've a lot of players. Just roughly, monthly active players, similar to the figures that Will talked about with regard to Netflix. And with these figures comes scale. And with scale, the solutions that work when you're much smaller don't really work anymore. And that causes a lot of pain, obviously. But it also gives you a very interesting challenge. And as your infrastructure scales, it becomes, quite large. It becomes increasingly diverse, and ultimately becomes difficult to triage. And as a security team, it becomes near impossible to have a full understanding of what's actually going on. And so you can't really quantify what your risk is, and incident response becomes pretty much impossible. And those are the type of challenges that we fixed. Well, sorry, not fixed, faced, and some of them we have fixed. Within Riot, we talk about becoming the most player-focused gaming company in the world. And to us, this means more than like being customer-focused in terms of how other companies would describe it. It really becomes down to like, hey, if we make this security decision, is this the best decision for the player? So for example, with things like Poodle, where you could turn off SSL v3 and you weren't vulnerable anymore. For us, we actually sat and we're like, hey, can we actually do this? Because where do people think gaming is most popular in the world? Like online gaming? What region? Yeah, China, Asia. They don't necessarily run the latest software there, right? Windows XP, legal or not, is still incredibly popular. And with that becomes, ciphers. And the ciphers that they use are not necessarily most up to date. So it's really symptomatic of the decision that we often face. Will we make the most secure decision? And if we do, how does that affect our players, right? Will we essentially prevent our players from logging in? So the security culture that has been around for the previous 30 years just doesn't really work for us. So here's some of the challenges more specifically with regard to AWS. Does anyone recognize this screen? He's gone. Where'd he go? Will's already gone. So this is SecurityMonkey. It is an awesome tool. It provides a really good holistic view. As a security engineer or security team, it really shows you what is going on in AWS. However, as you can see, there's 7,187 security groups that have a misconfiguration and present a risk. Now, I don't know about you, but I don't think I'm going to be able to fix that. So if you have a very developer-centric approach, which is what we have at Riot, similar to the one that Will talked about, can you imagine going to the developer and going, hey, buddy, you've got like 500 security groups to fix? You pretty much know what's going to happen, right? He or she is going to tell you to get lost, like they've got a product to ship. So for us, SecurityMonkey provides super breadth. It shows us when changes have been made. It shows us who the change has been made. We can drill into that stuff. But it doesn't really give us the tool that we need for what we want developers to do, because we really want developers to be able to fix their own problems. And with that, we don't really like to use tools that are a red screen. The second problem is, are people familiar with like static API keys in general? And that people like to upload them to GitHub, yeah? Awesome. So we've had a couple of those. Fortunately, we've got away with it because most people that detect them use them for crypto miners, and most crypto miners are noisy as hell. So we detect that pretty quickly. But we've done some testing on it. We wanted to see like how quickly the attackers get it. And within the past year, there have been like huge improvements. So GitHub now has a tool called GitGuardian, and it actually gives you a warning message that the API key has been deleted. And you get like an information message like this to the owner of the GitHub repo. And this actually, GitGuardian noticed it in 1 minute. How quickly do you think an attacker? Okay, anyone else? It's a good guess. 7. So 7 minutes before they actually contacted the STS token service on the AWS account. Our bug bounty took 3 days, so we fired all the researchers. The other one that we've been hit by a lot is hijacking. And hijacking is our biggest bug bounty expense. We've been running bug bounty publicly. It's in a private bug bounty, but it is public. So if we think if a researcher is very good, we will invite that researcher in, or if they've been recommended to us. So we work with HackerOne on that, and hijacking has been like our biggest expense. S3, CloudFront, Elastic Beanstalk. These are AWS services that essentially can be hijacked. Does everyone understand hijacking, or should I do a quick explanation? Hands up who'd like a quick explanation. Okay, cool. So essentially what happens is these services also have a partner, and that partner is Route 53. So that's a DNS service. So say, for example, you have your bucket and you're like, hey, I no longer need that bucket. You delete the bucket, but the Route 53 entry, which is like typically a CNAME entry, is pointing to that S3 bucket. Now, S3, CloudFront, etc., these are global namespaces, and a global namespace means that you just have to have an AWS account and then you can register it, right? So what happens is the attacker can detect that there's a dangling Route 53 record, i.e. pointing to an AWS resource in S3, CloudFront, or Beanstalk that doesn't exist. And then they can actually register that S3, CloudFront, or Beanstalk resource, which means that they can then control content, okay? So if I guess a sample case would be you have a website. In the website, you've got an iframe or a reference that points to the host name in Route 53. That then points to S3 bucket, but you no longer own the bucket. The attacker owns the bucket. Therefore, the attacker controls content served to the players. Does that make sense? Yep. Initially, with bug bounty, that was $7,500 per bucket, per hijack. So that's quite a lot of money. It's quite lucrative. You can easily automate that. You can easily search across multiple domains and search across all of the AWS namespace, etc. And then the final one that we did is we did shared accounts. So literally what we tried to do is basically think of an account as an holistic presence. But when you've got shared accounts, you've got shared ownership, which means shared accountability, which means no accountability. And as a result, it was very hard to triage. It was very hard to do incident response. We hit a lot of resource limits. So within AWS, you have a finite amount of ELBs, security groups, et cetera, that you can have in an account. So we hit those limits, which meant that we then had to talk to our account team, get the limits extended, go back to product team, go, hey, you can add those new things now, which slows down iteration and affects our ability to deliver to players. And then the final thing is once you've got everything in the one place, you have no isolation. So from a security perspective or a performance perspective, it's not ideal, which means that if one product has a vulnerability, it's much easier for that vulnerability to affect another product. So what we've done now is we've literally moved into segregation by account, which means that every account is based on a product. So each product should have their own account. And therefore, we have the segregation. We can literally give all ownership and accountability to, we call them gatekeepers. Each account has a couple of gatekeepers, and they're the admin for the account. And then they are the people who are responsible for following best security practices, but they literally own everything in their own little sandbox. But ultimately, when you take all those kind of things together, we were in a place where we were very reactive and we had a lot of troubleshooting and triage, et cetera. And the benefit of working in a games company is you've got really creative people who actually have cool art. So I don't do my images, but artists do. So, okay, so now I'm going to talk about what changes we made and how we progressed and the failings along the way, et cetera. So a couple of years ago, Etsy published this phrase, and it's really the phrase that we follow within Riot. Now that doesn't mean that we don't block, but think of it in a more nuanced fashion. What it means is that when we try to enable teams, or when we try to propose solutions, or when we try to secure products, we don't want to block those teams from iterating or delivering product. Otherwise, we're going to end up like that team in the Phoenix project. So has anyone read the Phoenix project or heard of it? You know that security team that no one wants to talk to sits in the corner, right? That is not the team that we want to be. We want to be like there to enable. We want to be there to collaborate. And it's impossible for us to scale to like every single team. So we think of like creating champions. We think of like engaging people. And then we think of like our tools. Our tools should enable teams to quickly iterate in a secure fashion. So when we sat back and we looked at the state of our AWS infrastructure, our services, and we knew that we were going to like, put more stuff into the cloud, we were like, well, what are we trying to do? Like, what's the main problem? And this is the problem statement that we came up with. So AWS, incredibly amazing place to iterate. However, you can iterate so quick and you can continue to like release, you can continue to develop, but there was no ownership attribution. So if you've ever done security incident response, doing response is hard enough in the first place, but doing response on something that shouldn't actually be there is sadly too common, but it's also plainly too silly. Additionally, if it is there and you don't know who is it, you end up then spending hours, sometimes days, trying to track down the owner of the service, right? So obviously, now in the world of 2018 with GDPR, et cetera, lack of ownership is increasingly important. Is increasingly costly. But back in 2015, for us, we weren't really thinking about GDPR. We were thinking about facilitating incident response, facilitating, security. And fortunately, AWS had a ready-made solution. There's a concept called tagging. And basically, that's adding metadata to your AWS object, in this case, EC2 instance. And that means you can assign that to an actual owner, a team, a product, et cetera. And we're now going to do a quick step back from that, talk about just show you the tools that are actually out there. And then we'll talk about how we implemented that ownership attribution with the tool that we developed called Cloud Inquisitor. So as you can see, KMS, that's the key management system. IAM is the identity, essentially authentication, authorization kind of platform. ACM is the certificate management system. CloudTrail, that's essentially the login system that does every single API key call. CloudWatch for events and alarms. VPC flow logs, compare that to NetFlow for your virtual private cloud for your network. And then GuardDuty. And GuardDuty is a new tool that they recently launched. And for us, it's been, there's some false positives, but it's been very beneficial for actually showing us from the perimeter what's actually happening on our AWS infrastructure. We've never had that visibility before. Okay, so you can see a lot of tools from AWS, from the community, SecurityMonkey, Terraform, Packer, Elasticsearch, and Kibana. We use these tools. There are a couple of other tools that we use, but these are the predominant ones, from getting a holistic security review, from deploying stuff, from treating everything that we do as code, i.e. Terraform. And then we developed a couple of our own tools, which we'll talk about in this talk, but we're going to focus mostly on the Cloud Inquisitor tool. AWS Key is our temporal API key solution. If you think your mind back to the GitHub static API key, we're trying to prevent that from even happening in the first place. I'll show you some slides at the very end because it's not open source yet, but Cloud Inquisitor is open source. So I want to talk about how we developed that, what we thought about, and the approach that we took. So at Riot, we have a concept called RFCs. So they're very similar to the public RFCs, such as like IETF or that the pip community use within Python. So Will talked about guardrails. We use RFCs not as an approval process, but really at Riot, feedback culture is one of our core tenets. And that's really to ensure that ideas can come from anywhere, but also not just we're not really a top-down org. There are some things that are prescriptive. We're very much a bottom-up org, and with a very active feedback culture, it enables us to, we feel, come to better solutions and make better products for players. So in an RFC, you draft an RFC. I'll show you a screenshot in a little while, and it talks about the problem space. It talks about who should be interested in this, and then it talks about our approach, why we may have disregarded other solutions, and then the proposed solution. So every time I've written an RFC at Riot, someone at Riot has literally edited or given me feedback that's resulted in a considerably better RFC. And there was one RFC that we wrote, which may seem quite obvious, right? Because as a security team, you think you build an office, and in an office, you should have firewalls, and you should have AV, and you should have network IDS and stuff. But when I first joined Riot, we didn't have the concept of a secure office. As a gaming company, our firewalls were maybe routers, because no game just works on port 443 or port 80, unfortunately. So we wrote an RFC on how we would build a secure office and how we would replicate that out across our 22, 23 offices globally. The RFC was 140 lines. The comments on the RFC were 850 lines. So like that's the kind of environment that we have. Once you propose something, it will end up in a better place, but you want to go in with like your helmet, your shield, and be prepared for feedback. So once you go through the terrors of feedback and you come out at the other end, we basically make it a standard through an adoption process. So if you think about scoping and programming, we have a top level scope, and that's Riot. And then each team or each kind of initiative would have, or product would have other scopes. And once there's enough scopes at that level that have adopted, we propose it for like the top level scope. And if you think about security, it really affects everyone in the organization. So most of our stuff is done at a top level scope. And that's how we build that alignment, and that's how we build standards. And that's how we get other teams to adopt our recommendations. Because at the end of the day, they've all contributed and they've provided feedback, and then ultimately they also own the solution. So here's some of the RFCs that we've written. Pretty standard, talking about minimizing access, securing data at rest, best standards and practices, like a more holistic view. And then finally, the ownership attribution. So we had the RFC adopted. And one of the reasons that it was, I guess, easier to get it adopted was that we shrank the change. So instead of enforcing tagging on, say, S3, on AMIs, on snapshots, on RDS, on like everything in AWS, we just focused on EC2 instances. So by shrinking the change, we wanted to like counter the problem that we saw in Security Monkey, right? We didn't want to take everything in. We wanted to get engineers and developers and product teams engaged in like, hey, here's this small thing. And if we do this small thing, we'll radically improve our security posture. And it also resulted in no decision paralysis because people were just focused on securing EC2 instances. So we went through the process, we got the feedback, we moved to adoption stage, and then it became standard across Riot. So then, being engineers at heart, we were like, cool, we get to write some code, we get to like make a product, and then we get to ship it. So Cloud Inquisitor moved from ideation to testing, to deploying, to testing again, to fixing, to testing, etc. And then we finally shipped it. What did we ship? Right? Well, we shipped a product that enforced tagging. So there were 3 tags: name, owner, and accountant. name, so you name your instance, owner, who actually owns it. That had to be an email address, and then accountant actually was used both by security and finance because it pointed to the team that actually owned it, so they could be charged back. It's always nice when you can leverage finance and make them the bad guys, but it was super useful to us. And then we do a notification process. So we notify you consistently over the first 4 weeks. And then if you don't tag it, we shut the instance down. So we don't terminate because once you terminate, it's gone. So by shutting it down, we give like an 8-week leeway. Version 2 of the RFC, which we just recently got adopted about 2 months ago, we're going to switch this from like to 1 week and 3 week, I think, right? So, but again, this was us trying to change culture, trying to improve the security posture, but keeping everyone on side. So like there's a 16-week chance that you can still, return your product to service if you notice that it's suddenly needed. So this is all awesome. Security's improving. Everyone's aligned. Everyone's excited. And then Cloud Inquisitor made a mistake, and we took down clubs. So within League of Legends, clubs is an essential service. Or sorry, not an essential service, but an important service. It doesn't affect how you play the game. It doesn't affect your rank. It doesn't affect what other people think of you. What it does affect is people join clubs. So it's a social aspect. It's an engagement aspect. So when you play the game, you make all these friends, and then you can join your own club. And then your club is kind of like the group of people. So we took that down. As you can see, we took it down in October 2016. And as you can see from the slide, it was still down in November, which for a security team that considers themselves player-focused and developer-centric is not the best feeling. And having your tool called Murderbot didn't feel too good. So let me show you how it felt on the night, right? So, hey, we're getting a list of teams that have been affected. You can see that it's 11:53. This is LA. We're a global team. 11:53 in LA is Central Time. Pretty late, right? That's almost 2 a.m. on a Saturday morning. In Dublin, that's 10 a.m. So Irish people were renowned for drinking. 10 a.m. on a Saturday morning, you pretty much want to be sleeping over your hangover, right? Instead, some of our engineers in Dublin were looking at their AWS infrastructure. So this went on for a while. You can see that I was still getting feedback. Auto-scaling groups, people were trying to understand what the actual problem was. You can see people feeling pretty strongly about things. Now, no one's actually swearing or maybe they're swearing in private rooms, but they're not swearing in the public room. But you can see things that come about here, like this is a clear misalignment on the philosophy. So there's an RFC adoption process, there's the discussion process, but clearly some engineers still feel, misaligned with it. Now, this guy didn't take the opportunity in the RFC process to send that feedback, but this was something that would be followed up in the root cause analysis and lessons learned. This was amazing, right? This was the product lead of the club service. So she's actually like calming the situation down. And that's because of the culture that we've taken several years to build, right? We've engaged these teams, we've reached out, we've tried to be proactive, and we screwed up. But, people were still understanding. You can also see that Harry Potter started getting involved, and I ended up in Slytherin, I think. Although I always thought I was Gryffindor, but whatever. So yeah, look, it sucked. We received a lot of feedback, but I obviously still work at Riot. So we conducted an open and transparent root cause analysis. We literally just bared our clothes publicly. This is probably the most challenging time of my life at Riot over the 5 years. And it was clear that there was a lot of confusion despite the actual adoption. So people didn't know what an invalid tag was. People were like, hey, why do I need to do this? This is the cloud, everything's magic, nothing actually exists. And we actually got an independent Rioter, so someone outside of our team and someone not affected by the downtime to conduct the root cause analysis. And we got a lot of awesome feedback on that. So we had one of the senior leaders in engineering actually call us out and go, by doing the root cause analysis so transparently, you actually proved that you were part of engineering more than you proved before the actual issue. So that showed us that we were on the right track. Our communications and planning sucked. We thought we hit everyone, but we didn't. So the message there is really, if you think you've communicated, go again, like over communicate. We didn't hit all the required groups. It was clear that the RFC adoption process wasn't fully aligned with everyone. So there was assumptions. And then lastly, we obviously had bugs. We didn't intend for the tool to finally do the murdering on a Friday night, but we misplaced a 0 and a 1. So these things happen. We went back, we fixed it, we improved the UX, we made it easier for developers to actually understand what was going to happen. We also made it easier for them to understand what they had to do in order to solve the lack of tagging or lack of compliance. And we should have done this the first time, but we actually did it the second time. We manually went through every single instance that was scheduled to be shut down and ensured that it wasn't aligned with an important product that was live. Completely over-indexed on communication and had lots of discussions. And one of the hidden benefits of this whole process is that at Riot we have a much better disaster recovery process now. So that's awesome. And then finally it was adopted and we implemented it. And yeah, I think it's shut down like 3,500 EC2 instances in the past 15 months. So like that's a considerable amount of money saved from a financial aspect, but also a huge reduction in risk from a security posture. So this is what the tool does. So besides the ownership attribution and removing of data that you don't need, it actually ensures that features are turned on. So features such as CloudTrail, features such as VPC flow logging. We are probably going to add in guard duty and one or two other things. But essentially, it makes sure that every single account in our fleet has security features turned on. Worst thing that can happen in incident response, I'm sure it's happened to others, not including me, not just me, is doing an incident, thinking that you had to log in on a certain device or thinking a proxy server is doing a certain thing, and then you go to look at it and you're like, oh, it's not there. One of the things we got caught in AWS is on an ELB load balancer, if you don't enable login, which is not there by default, and your web server has an instance, for example, an incident, there's no Nginx logs, right? So you think you go to your instance, you think you enable that in your instance, you don't. You enable it on the load balancer, and it's not there by default. So that's really important for us. DNS hijacking, so that's where the Route 53 example that I talked about. We think this tool has probably saved us over $1 million in bug bounty bug bounty tickets for domain hijacking, subdomain hijacking. It also enables us to manage our IAM policies across our whole fleet. So we have over 60 accounts, I think 65 roughly now. So we manage that through code. So this is a screenshot showing our internal, one of our internal repos. And this is how we manage AWS policies across. So we take a slightly different approach from Netflix, but this enables us to manage the accounts from a centralized place with auditability. Enables us to easily change policies and push them out widely. Excuse me. And it's also done transparently, right? Everyone who's a Riot engineer that has access to GitHub can see the policies, and they can make pull requests to suggest feature changes. So this is configuration as code across all of AWS. So this is how this is the architecture of Cloud Inquisitor. So we call it Sync for short. So apologies for changing the name. But essentially it runs in one account, and that's our security account. And from there it uses assume role, and it assumes a role in each of the accounts, collects its information, and then brings it back to the central security account where we have an RDS instance that runs MySQL. And it uses like a collector auditor format, which means that the collector can be cloud independent. So connects in, pulls the data back, stores it in the database, and then the auditors run against the database to figure out how the tagging is done, or if CloudTrail is enabled or disabled, for example. So on the front end, we've got AngularJS running on Nginx. Everything's done in Python, Python 3.5 plus. I think we're on 3.6 mostly, but we support 3.5. SQL Alchemy. And then we deploy it through Packer. That's how we do our orchestration and production. One of our guys, because he's hipster, I think we describe him as. So he has developed a dev environment in Docker. The funny thing is that his Docker development is 6 Docker containers versus 1 VM. But I think partly that's meant to make things easier. This is what it looks like. So you can see that in this screenshot, which is from a few months ago, we've got just over 7,500 instances running. We can see what's stopped. We can see all the instances that have public IP. If you look on the left-hand side, you can also see there's like a search functionality. So Cloud Inquisitor acts as our asset inventory for AWS because it pulls everything down. And then we go through every single account. So the really nice benefit here is that a developer or a product owner can go in and see the posture of their account based on RFC compliance. So they don't actually need to engage the security team. We can modify the configuration for an auditor in the UI. So you don't actually need to know the code in order to do that. You can increase the frequency. You can modify regions, etc. And being a security team that's focused on engineering and being developer-centric, we want to dog food our own recommendations. So in this instance, you can see that there's an audit log for a change that I made. So you can see that it's me, you can see what I did, you can see the date, and then you can see the actual data in a JSON format. So there's no point in us making recommendations to developers or product teams and not doing it ourselves. With regard to the notifications, the tool will email the owner of each account. So as I mentioned earlier, we have a gatekeeper format. So each account has 2 to 3 gatekeepers. They are emailed with regard to compliance on the account, and it gives them the instance, the account, the region, the tags that are missing, and it gives future notes, and it gives like the status. So it actually tells people what's going to happen, but it also tells them how they fix the lack of compliance. And then finally, if they need more information, they can go into the UI and they can go and look for everything across their account. And they can apply filters, and they can basically dive in detail into what they actually want to do. So here you can see the accounts. Here's the region instance. Obviously, it's grayed out, but you can see the actual instance ID and the account. So what was our solution? Well, we shrunk the change. We just focused on EC2 instances. We didn't want decision paralysis. We wanted to keep people emotionally engaged. We wanted the developers and product owners to actually want to make the changes that we were encouraging them to make. We took a lot of feedback. We listened to the feedback, and we moved to the adoption stage, following a process that everyone across engineering had agreed. And then we made it a standard across Riot. So everyone was bought in. Everyone had the chance to give feedback. And in essence, everyone owned the RFC and or the standard at the end of the day. So that's the change we did. What are we going to do in future? Well, we've obviously open sourced it. We're collaborating in Slack or GitHub issues, but Slack is our chat room. This is the URL, github.com/Riot Games. Riot Games is our org in GitHub, and then Cloud-Inquisitor. And within that repo, you can find out the details for the Slack room, etc. Our roadmap is in our docs, ideas that we have, and like every bit of code that's out there on the internet, we would love pull requests. One solution I touched on earlier is OSKey, and that's our solution to minimize the use of long-lived static API keys. What we do with this service is we provide temporary AWS API STS tokens, and they live for anywhere from 1 hour to 12 hours. So this greatly reduces the impact if the key is leaked. We also have activity monitoring on the tokens, and we found it incredibly useful. It's got quite good adoption rates. We have a web UI where you can just open up a browser, or we also have a command line tool which we can link to down here. But that basically is it gives you back your access key, your secret access key, and your access token. And then based upon how you want to configure it, it can live for 1 to 12 hours. And it's also backed by Duo, as you can see here. So we have 2FA. This authentication actually authenticates against our SSO. We use one login, which talks to our Active Directory infrastructure. So all our accounts are actually federated. So you need 2FA to get onto the console. You need 2FA to generate a temporary token. Obviously, with static API keys, you don't need 2FA. But our whole approach, by default, our whole approach here is to provide solutions, secure solutions that can enable developers to do their work in a non-blocking fashion. And like all good products, we have some measurements. So we can actually see, how many users there have been in recent times, how many keys were generated, et cetera. And this is Elasticsearch with Kibana. And this is really good because one of the things that we want to do is not just develop products. We actually want to develop the measurements for the products as well, because we don't want to be creating tools that people don't use, right? So it's not just about having measurements to present to leadership or C-level. It's also about having measurements to actually understand what are our teams doing. So the features that we're going to do is we've introduced EBS volumes for tagging into Cloud Inquisitor. We're going to work on snapshots, S3, and AMIs. We're also going to integrate compatibility with organizations, which will make everyone's job a lot easier, rather than having random AWS accounts in different places. The really cool thing is that through our collaboration and our RFC process and working with other teams, we're now beginning to receive features, not just pull requests from other teams. So we've had one team create a GDPR auditor for Cloud Inquisitor. So we haven't released that publicly yet. There's still a lot of testing being done, but that's been super cool. And we're going to do a temporal auth for services. So our temporal auth solution that we have at the minute is just for users. But as everyone knows, things like Jenkins, for example, need access also, right? And if you're an attacker, Jenkins is a super attractive place to attack. There's a lot of good things, a lot of awesome credentials there. So that's what we're thinking of is how do we secure the services as well? Because they don't work as well with sort of temporary credentials. So takeaways: when you're enacting change, make sure that you communicate and build constructive relationships. Once you get folk passionate about what you want to do, it means that things are so much easier. The emotional involvement means that the feedback is much more actionable. It means that people will listen, and then you can iterate with them to make a better solution. And ultimately, they feel that they're going to own the solution also. Use the best tool to solve the specific problem. So thinking back to SecurityMonkey, it's an awesome tool. Gives really good holistic view. It gives history, but from a proactive perspective, it's not what we wanted. It's great in incident response. It's great for reactive stuff, but a developer's not really super interested in going to look at it. So focus on solving the problem at hand. And then the other thing is when you develop a tool and you've done the culture engagement and you've got the tool developed and you've got it shipped, always be conscious of like how many false positives. Like you don't want a screen of red. So I call this boil in the ocean. Anytime we've presented a developer or product team a screen of red, they literally just don't want to do it. And they like walk away because the problem's too big. And that's my talk. Any questions?
Hello. Hi, this is a question from a remote attendee. When updating tag information, are there any regulating controls to ensure that the information about who owns whichever bucket is correct, or is it all manually set and manually changed?
So we haven't done the tagging as of yet for buckets. we're in development on it. The tagging is freeform, but with Cloud Inquisitor, for example, what we have done is we've allowed the name and the accountant tag to be freeform, but we obviously look for the key to be of a certain format. What we've done with the owner is we've insisted that the format, i.e. of the value for the owner key, has to be a valid email address. So you can code it in, but I don't believe there's anything that AWS enforces out of the box. Does that answer the question?
I was wondering if you looked at HashiCorp Vault and compared that to what you guys built.
So for a credential storage perspective, so we haven't gone into like storing credentials anywhere. There are teams within Riot so our infrastructure is very hybrid. We have a lot of stuff in the cloud, but because we're a gaming company, we have to have a lot of bare metal stuff because we need super low latency. So there are people on the bare metal side of things or the slight hybrid side of things that use HashiCorp Vault. I know there's like one team that specifically uses it, but for us, from the credential store, no, it just didn't fit any of the things that we wanted to do.
Hi, I'm so happy that you shared your experience with that soft fail with rolling something out. And I've always kind of looked at things in terms of people, process, and technology. And we're starting our transformation right now. And the biggest struggle isn't figuring out a technical solution. It's like getting people on board with the change in the process because things work a little bit different. Do you have a couple of like specific technical suggestions in getting people more engaged while you make these changes in the process?
Yeah, so I read a lot of books on it because I made a lot of mistakes on how to communicate. So it's really trying to communicate from a listener perspective. So like, what does the audience actually want to do? And communicate not as a security person, but thinking of it like from a product person or as a development manager or as a developer. And to get like a lot of our RFCs have to be go at a holistic high level, at a holistic top level. So what we always do is we figure out like which teams are super passionate about these changes, and we engage with them. So we usually engage with like the tech lead or the product lead or someone else that we have a really strong relationship with. And before we publish an RFC, we have like a small group of people that we'll link up, reach out to. And the other thing is, when you get feedback, just really show that you listen to it and try to improve the solution. And when things aren't working on written text, just take it off and try to meet the person for a coffee. Because like so many times, like it just turns into like a crap show, right? Yeah, it's like keyboard warriors against each other. Like a couple books that really helped me were like Thanks for the Feedback and Radical Candor, and I think Work Rules from Laszlo Bock was really good. But it was really trying to think of things from like the audience perspective. And like the RFC that touched upon the Secure Office RFC, we got 840 lines, 50 lines of comments. So the RFC that we first came out with was like 80% of the solution that we wanted to implement. But what actually got implemented was something like 65% of the solution. But instead of having 20% adoption, it had 100% adoption. And the way so it's really about trying to find the champions, trying to like listen to their feedback, act on it, and then get like enough people kind of on side and get them emotionally involved and get them to feel it's their solution also. But just always like listening and acting on feedback, because it's so easy to just burn the bridge. Does that help? Yeah. Did you have a question?
So you were talking about Cloud Inquisitor, and you were talking about your infrastructure that you have.
Yeah.
You mentioned RDS. How do you have that deployed? Do you have like a multi-AZ deployment with that, with read replicas, or how is it set up?
Yeah, we don't have read replicas. We just have like one core instance, but we have backups, and we have like the backup in a different AZ as well. We don't have multi-region. We don't really need multi-region for what we do, but we've been able to restore it pretty quickly. It's not like a critical service in terms of like, it's not, by it going down, it doesn't take down League of Legends, if that makes sense. So for example, the database infrastructure that our accounts team has is multi-region, multi-AZ. Its downtime to like, its recovery time is much smaller. Like for us, it just means that there's like lack of compliance maybe for 30 minutes. And notification emails may get repeated, right? So it's not really that big of an impact.
So you're not worried about RTO and RPO really with Cloud
Sorry?
Inquisitor then?
Not
You're not
worried.
as concerned with RTO and RPO then with Cloud Inquisitor?
We're personally not, but maybe we're missing something.
No, just- Okay.
We're also not in US East 1. So by being in US West 2, it's proven to be a lot more reliable. Like we made a conscious decision to use US West 2 as our primary region.
Okay. So you aren't using read replicas though, you said?
No.
Not enough traffic on it?
No, there's really not.
Any
It's not.
Elasticache or anything like that?
No, we don't need it.
Thank you.
No problem.
Thank you, Mark.